So a friend of mine who's also in security was taking a ride share some time ago with a guy who turned out to be a loss prevention officer at a major retailer. And he said, I'd really like to get into cybersecurity. And my friend said, well, there's a lot of parallels, but there's actually quite a bit that's different. And we're just going to start things off talking about that a little bit and some of the things that we see when we're doing digital development in a physical world context.
So let's say we've got our average retail store, we've got aisles, security cameras, and our loss prevention officer over here in the corner. Now let's say the business wants to implement some fast changes to increase revenue. So maybe they add some new doors and automated checkout to get customers in and out as fast as possible. But did loss prevention really have the time to adequately react to these changes, maybe install some new cameras or even hire new guards? Now let's say for some reason the management wants to move all of the big money makers into one corner of the store, but that's where the soda used to be. Is that area really set up to handle that kind of risk?
Yeah, so we could go on. There's lots of crazy stuff like that that could happen, and it sounds ridiculous in the physical world, but this is what happens in digital all the time in our experience. So here on the left, we have a typical security team, and on the right, we have a development team, and everyone seems happy, right? There's a pretty good ratio, but in reality, most organizations really don't have that many skilled cybersecurity people to go around. And in fact, a lot of the time, security is outnumbered by dev by a factor of 100 to 1 or worse. So those few security people usually have a lot of other responsibilities in the organization. It's probably not realistic to expect them to stay on top of everything that we're doing. And meanwhile, we encourage development teams to deliver business value faster, deploying weekly, even several times per day. I don't know about you guys, but I don't really find that it's very realistic to think that somebody's there to watch over everything that we're doing. Meanwhile, I think, or at least I've experienced with a lot of teams, that there's kind of a tendency to assume that there's some hidden figures looking over our shoulders, making sure that everything that we do is safe and secure. And the thing that we want development teams to start asking a little bit more deliberately is there a security team watching over everything that you make? And the answer is no, so we need to start doing more.
For example, at ThoughtWorks, there's 3 people on our core security team, but there's over 200 thought workers on our internal delivery teams. And there's so much context switching involved between tech stacks, app risks and requirements, even the security maturity of the teams themselves, that it becomes really easy to engage at a surface level and then move on because you have so much to cover. But as we all know, those important conversations only really happen when you can dig deeper. And unfortunately, we just don't always get the chance to do that.
So thankfully, I think in the last 5 or 6 years, our industry has really started to collectively acknowledge the fact that this old approach that we were describing doesn't really fit well. We've seen buzzwords, concepts emerge like DevSecOps, rugged DevOps. There's also SecDevOps and DevOpsSec, which is unfortunate. We're staying light on the buzzwords in this talk, but these things embody some pretty important principles and concepts, and they're worth following and learning about.
So buzzwords aside, what do we do about this? Well, you don't have to be perfect. Security is not an all or nothing game. It's kind of like this photo. You don't have to be the fastest person running away from the bear. You just really don't want to be the slowest. Similarly, you don't have to implement every conceivable security measure. You just don't want to be an easy target. A lot of attackers are just looking for a quick payoff and some low-hanging fruit. And if we can make it just a little bit harder for them, we can avoid being that target. So what we want to do today is talk to you about some concrete ways to remove that low-hanging fruit and look for opportunities to continuously improve.
So for a lot of development teams, it's not really that clear where to start, and there's a lot of ground you can cover. And we're going to talk about a few quick things, quick wins, really, that we encourage development teams to do from day one. You can do these things at any time over the course of your project, however. And for the sake of simplicity, we're going to divide things conceptually into 2 buckets. One of them is automation, or taking an automation-first approach to security. And basically, if we can put these things into our backlog from day one and just try to get them out of the way as fast as possible, it's going to be better for the team, because we want to make sure that the team has all the tools that they need right from the get-go in the project to deliver more safely without impeding them later on.
So for our second conceptual bucket, we don't want to start off on the wrong foot, and so we need a strategy to get things right. And fortunately, there are some conversations that we can have at the beginning to help us do this, such as how do we collaborate with our security team? Or are there best security practices or even common defects for our tech stack that we should be looking into? The difference between starting development armed with this kind of knowledge and maybe scrambling later to make a design change can be really huge. So to illustrate this, if the first security check that we're doing is a penetration test at release time, that can not only be incredibly expensive, but also incredibly disruptive to our workflow and even to our delivery schedule. So detecting these issues earlier on actually fits really well into Agile because it allows developers to spend less time worrying about fixing defects and more time focusing on delivering value. So this isn't to say don't run pen tests, but rather don't wait to find out what horrifying things lie in wait for you until you run your pen test. Also, we don't want to be paying some expensive human to find a basic vulnerability like cross-site scripting. We want to make sure we're utilizing their human brains for far more sophisticated attacks than that.
So if we really want to accelerate development and deal with some of the challenges of scale that we were speaking about earlier, we have to rely on automation, right? And there are tons of common problems that arise over the course of a software project that we can deal with very early on and continuously ongoing after that. And suffice it to say, we're really big fans of automation. And the one caveat here, though, that we've seen cause some problems is that you need to understand what the automation does and how it works before putting it in place.
So patching is what I think of as the epitome of quick wins. We all use third-party libraries, and when there's a vulnerability introduced into one, which happens a lot, we need to know about it so that we can do something about it. And there are open source tools like Hawkeye, which you can put right in your build pipeline, and it'll let you know when a dependency that you're using has a known vulnerability. You can even configure some of these tools to automatically update to the latest patched version. And if you're willing to invest in something like a Canary build, that's really worth investigating. So we know that you know to patch your systems. There's tools to help with that as well, like Nessus and SolarWinds. You can point them at your known hosts, and they'll scan them for vulnerabilities. All of this, by the way, is just as important for pre-prod as it is for prod. And if you needed a little bit more of a reason, here's a recent real-world example of why patching is so important. Attackers took advantage of a vulnerability in the version of Apache struts that Equifax was using, and the patch for that had been available for 2 months. So Equifax is by no means unique in this way. They're actually pretty indicative of the status quo. And when you look at a headline like this and you think about what else could go wrong, that status quo is pretty scary. So the moral of the story here is really patch, 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 because this is something that the delivery team 100% could have helped avoid.
Yeah. Of course, there's a lot more than patching to worry about when we're doing custom application development. What I spend most of my time speaking about with people is application security, because it's not a very well-solved problem, and it's something that we see teams getting wrong all the time, as an industry that is, and within ThoughtWorks, it just happens. This is a really great image that a company called Contrast Security published last summer as a result of some analysis they did with their application security tool. It shows that on average, 21% of an application is comprised of custom code, and the rest is third-party libraries, like what Sarah was describing. And yeah, you're going to have vulnerabilities in those third-party libraries, but there's a lot of stuff that comes up in our code as well. And they showed 25 serious vulnerabilities on average. So hopefully people have experience using static analysis tools for security. For those who don't, you've probably used SonarQube or other popular tools like that, and it's conceptually quite similar, analyzing source code and binaries to identify patterns that might be indicative of security defects. And these really allow us to reduce the cycle time to knowing if we've introduced something wrong, which, if we're moving fast, is obviously very important. And in fact, some of them even integrate right into the IDE and give a spell checker-like feedback as we're developing code if we've done something wrong. One of the really great things about introducing a tool like this is that it provides us fast feedback. One of the big challenges that we have on development teams is we don't really necessarily know whether we're doing the right thing all the time. So if we don't know if we're doing right or wrong, how can we expect people to possibly get better? On the top here, we have a few commercial tools, and on the bottom are some free and open source ones that we've had good success with. And the free ones are a really good place to get started. It's helpful to keep in mind, though, that they don't necessarily have the same breadth of coverage. The commercial ones, on the other hand, there's a lot of different competing ones out there. Some of them have really good marketing and talk about things like DevSecOps and all sorts of things like that. So you want to invest some time early on and make sure that you're really picking the right tool for your tech stack and your code and whatever you're doing within your organization. In particular, you really want to watch out for tools that generate too many false positives, because if we're generating alerts all the time, the team ends up suffering from alert fatigue. And of course, they're just going to end up ignoring it, which isn't something that we really want to do. And commercial tools are, well, enterprise quality software as well. So they're very expensive. It's worth making that investment early on. Now, one of the major caveats here is that you want to make sure that the team actually knows how to deal with the tool. It used to be the case that a security team or security specialists were responsible for this, but we're really emphasizing and advocating pushing this responsibility to development teams. It doesn't really make sense for one of your first security people to go over everything that's happening all the time. Maybe instead we can have the security team help out when we're not really sure about things, or while we're getting started, at least get them to maybe give it a second look and make sure that we haven't missed stuff. And as an example of why it's important to have at least a few people who understand how to use it, I worked at a client a few years ago where they were using one of these tools to scan a legacy code base, and there were in the order of hundreds or even thousands of vulnerabilities. And they looked at it once a week for 1 hour per day, and the sole developer who was responsible for it wasn't really that strong in application security. So as you might imagine, they had a really hard time figuring out whether or not things were significant findings, figuring out what to prioritize, and a lot of stuff probably languished as a result.
So protecting secrets might seem kind of obvious, but you'd be surprised at how prevalent this issue really is. And by the way, when I talk about secrets, I mean login, credentials, API keys, anything that you would use to authenticate to a system and prove who you are. So using a password manager here is really only half the battle, because you still have to think about questions like, are we rotating passwords when team members leave? Or are credentials being shared between people or between environments? Planning for failure is a big part of security, and if a shared credential is used in a breach, how easy would it really be to figure out what went wrong? So all of these, by the way, are examples of things that we've seen and more. Just recently, we saw a developer check an AWS secret key into GitHub, and within hours, someone had sniffed it out and started mining Bitcoin on the company's dime. They ran up an AWS bill of over $100,000. And this issue is prevalent enough that both GitHub and AWS are actively looking for leaked keys because they want to avoid that exact scenario. So as you might imagine, as time goes on and these kinds of practices become entrenched in the way that your team works, it gets really hard to change things. So setting this up right from the start can really save you a lot of pain down the road.
So one more thing on automation, and that's don't forget detection, right? Our applications, our systems generate all sorts of logs, and quite often these go largely ignored, which is pretty scary. If we want to get serious about security, we have to plan for failure, as Sarah was just saying, and that starts with knowing when we failed. It's pretty hard otherwise. So a few things really quickly. Make sure there's a shared understanding of what we want our custom applications to log and when. Ship the logs off to a centralized monitoring system like you guys have surely seen Splunk or Elk. Your security team might have a SIM or some system like that. Work with them to figure out how to set up alerts. Pretty straightforward. But that's enough about automation for now. What about training? I don't know about you guys, but I've sat through so many 1 hour compliance or security-oriented trainings that are mandated by the organizations that I work with. They come annually, and you have to sit and listen to somebody talk at you for a couple hours and maybe answer some multiple choice questions. Is it really realistic for people to get better when that's all the training they get? Probably not. We need to find better ways to educate people, right? And that's not to say that instructor-led training doesn't help. We have a great training program in ThoughtWorks called AppSec 101 that has been very well received globally, but in-person training doesn't scale that well, and we want people to do this stuff on a continuous and ongoing basis. So we've been experimenting with ways to bring together the best content that we can find online, in addition to finding pretty interesting interactive activities so that people can keep doing this stuff. And there are some really cool platforms out there that have come out in the last few years. One of them that I would recommend taking to your teams today, Hacksplaining, completely free, has pretty interesting interactive tutorials on common vulnerabilities, nice ways to mitigate them. There's Secure Code Warrior, which we experimented with a few months ago. It gamifies security training, so people get to compete against each other and do online challenges, basically, which was actually pretty fun. And Pentester Lab is the last of those. Teach people how to do some basic web application exploratory security testing, which is great as well, whether you're a developer or a tester.
and it's really fun.
Yeah.
So we just talked to you about a lot of things that we think are quite important, but they're really just the foundation to be able to handle security as the continuous task that it is. So maybe this slide should actually be titled "Security is Never Done," because security is never really done, but we don't want to give you an impossible task. We would rather set you up for success. So in this vast world of security where you can't necessarily expect a typical dev team to be well-versed in an array of attacks, how do you really bring what matters for a team to the surface? Well, we've developed some threat modeling resources based on our experiences of what does and does not work. And one tool that we really like is a set of common exposures and threats from our colleague Jim Gumbley. And it's incredibly useful for having realistic and productive conversations about security with teams from any experience level. And we find the most success when all roles are involved in this discussion. So another way to think about this is you wouldn't consider something done if it's buggy or unreliable, and we shouldn't consider something done, and we shouldn't ask our users to trust us with their data if security hasn't been prioritized. We want to normalize security, and that means putting it through the same analysis process as any other requirement. And when we involve analysts in that discussion, when we're coming up with the definition of done for a feature or functionality, when we work with them, we can bake security requirements right into that definition. So we can't pretend to give you all of the answers in an 18-minute talk. There's no real easy answers. But if we can figure out a way to be asking these questions and having these discussions continuously throughout development, we can really find ourselves in a much better place.
Thanks. We're actually over that 18 minutes, but really, I think it's really important for us all collectively as software developers or people on teams to ask the question, hey, is there really a security team providing us oversight? And if not, what can we do about it to be better? Thanks.
Thank you.